Hi everyone, this is a video to demonstrate how to balance reaction equations. We're going to do a couple of different examples. The first one is reactions between ionic compounds. So I've selected two ionic compounds as an example. We're going to write the equation for the reaction between aluminum nitrate and lithium sulfate. So first we have to write the correct formulas for those. This is always the most critical first step. If you get the formulas wrong to begin with, you're going to end up with a balancing nightmare. We go to the periodic table, and we know that from the column that aluminum is in, that it is 3 plus, and it is with nitrate. Nitrate is the polyatomic ion NO3, which has a 1 minus charge. So to get a neutral compound, we need to have three of the nitrates. That's reacting with lithium. Lithium is in the first column of the periodic table. Everything in that column in an ionic compound has a +1 charge. Sulfate is the polyatomic SO4 with a 2 minus charge. To make that a neutral compound, we need to have 2 of the lithiums. When these react, anytime we have 2 ionic compounds, the cations and the anions will switch. You may have learned this in high school as what's sometimes called a double displacement reaction. So the only thing that the only thing that the 3 plus aluminum can be with besides nitrate is with the sulfate. So that's what we're going to write it with. So on this side, we're going to have aluminum with its 3 plus charge, with sulfate with its 2 minus charge. And this is a situation we've encountered a number of times. When we have 3 and 2s, we have to bring them both up to 6. So to get 6 plus charge for aluminum, we need 2 of those. To get 6 plus charge for sulfate, we need 3 of those. This is another example of why you need to have your polyatomic ions memorized, because you need to be able to look at sulfate and see SO4 as a single unit and know that we need 3 of them, and to kind of ignore that 4 for the purposes of making the compound formula. All right, so now we've got aluminum sulfate, and then the other compound that's going to get created is between the remaining cation and anion. So that's going to be lithium, which is +1, nitrate, which is -1, and that's already charge neutral. So that's a good formula. All right, so now that we have our formulas written correctly, now we can go back and start to balancing. We always work left to right and never working backwards. So we've got aluminum, we've got 1 aluminum, and we have 2 aluminums on the product side. So we need to put a 2 coefficient out in front of the aluminum nitrate. Remember that now affects the nitrate as well as the aluminum. So now we have 6 nitrates here. Remember, because the coefficient and the subscript are effectively going to multiply. So now there are 6 nitrates on the reactant side. Over here on the product side, we only have a single nitrate. So we're going to put a 6 out in front of the lithium nitrate compound. Move to the next ion. Now 2 lithiums on the reactant side, 6 on the product side. So we're going to put a coefficient of 3 in front of lithium sulfate. There are now 3 sulfates here. Again, remember, sulfate's a single unit, so we don't look at that 4 because the 4 is part of the sulfate. So there are 3 sulfates, there's 3 sulfates on this side. This reaction equation is now balanced. Hooray. All right, the second example we're going to look at is what's known as a combustion reaction. Combustion is a fancy name for the reaction between a compound. In this case, we're going to use ethane. And when ethane, and you don't know how to do this yet, that's the formula for ethane. Combustion just means react with oxygen. And every time there's a combustion reaction, that produces CO2 and water. This is something that I'm not going to force you to memorize. You're going to do this so often, you're going to know the answer within the next week. So again, this is the same process. We're going to work left to right. The only difference here is that we're going to look at the individual atoms, because there's no polyatomic ions like we had up in the earlier example. We're going to treat each of the atoms separately. So the carbon atoms, the hydrogen atoms, and the oxygen atoms, we're all going to deal with those separately. So on the left-hand side, we have 2 carbons. On the right-hand side, we have 1 carbon, so we're going to put a 2. On the left-hand side, we have 6 hydrogens. Over here, we have 2, so we're going to put a 3 in front of that to make it 6 on both sides. Now we run into an interesting problem. So we have 4 oxygens here in the CO2. We have 3 more in the water, for a total of 7 oxygens on the product side. So we need to make 7 oxygens on the reactant side. Well, we've already got 2, and remember, we can't add or subtract. We can only multiply when we're balancing. So the trick is that what we do is we write 7 halves, because 7 halves times 2 would give us 7, adding up to the same number on both sides. Personally, I am perfectly happy for you to leave the reaction equation balanced this way with a fractional coefficient. Some people prefer that you multiply the whole thing by 2 to bring everything up to a whole number coefficient, and you're certainly welcome to do that or leave it alone, as I said. If you multiply it through by 2, that brings us up to 2 ethanes, 7 oxygens, 4 carbon dioxides, and 6 waters. One thing that's really useful to do is to go back and double check that you did it correctly by counting everything up again. So here we have 4 carbons and 4 carbons. We have 12 hydrogens and we have 12 hydrogens. We have 14 oxygens and we have 8 plus 6, which is 14. So everything balances out in this equation. You can do the same thing back up here in our reaction involving ionic compounds and just double check. 2 aluminum, 2 aluminum. 6 nitrates, 6 nitrates. 6 lithiums, 6 lithiums. 3 sulfates, 3 sulfates. It's always best to double check these at the end to make sure that you've got the right answer. So again, this is demonstrating how to balance reaction equations. We always work left to right. Make sure that they're the same number of either atoms or polyatomic ions on both sides, and work systematically if you have left to right. If you have made a mistake with the formulas, it won't work. So if you get in a situation where you keep having to change coefficients back and forth, it's very possible that you have the wrong formulas for the compounds, and you should go back and double check those before stressing yourself out anymore. All right, thanks.